And then we have question 3, a gas sample. All right, I'm going to start again by underlying and explaining the key terms. I think the first key term we're going to have here is gas. The fact that this is a gas means you are allowed to use the universal gas law, so PV equals to nRT. I think the assumption here is that this is an ideal gas because we don't really deal with real gas behavior in high school. So PV equal to nRT. You also given the mass of the gas. So I'm just going to write M here. This is a unit for mass. Grams is mass. And it occupies 245 milliliter. This is the unit for volume. At 100 kilopascal, this is pressure. And 25 Celsius degree, this is temperature. And the question asks for the identity of the gas. So I think once again, I am going to summarize the information. I think I have underlined all the key terms. We have mass of the gas being 0.020 grams. We have volume, which is 245 milliliter. Pressure of 100 kilopascal and temperature of 25 Celsius degree. The question asks you to identify the gas. So we're looking at identity of a substance. Okay, now the fact that this is a multiple choice question it's also very helpful because otherwise you might have to do a little bit of guesswork. I think another thing that's important, let's just explain a few things. First of all, the only equation or relationship per se that I have that can link at least these 3 quantities together is the universal gas law. At this point, I don't know how I am going to use the mass yet because, I mean, if you think about it, there are 2 things you can do with mass. You can either find, well, one thing, which is to find the molar mass or the number of mole, depending on what you're already given. But mass is definitely not one of the quantities in this formula. But these 3 definitely appear here. However, the main thing to remember, I think, when you use the universal gas equation is you need to have the units correctly. So pressure has to be in kilopascal, volume has to be in liter, and temperature has to be in Kelvin. So right now, my volume is not in liter yet. I'm just going to convert it here. You definitely can do it later, but I think this is 298 Kelvin. I don't have the number of mole of the gas, but I know the gas constant, which is 8.31, and you are given this formal value in the data book. All right, so I've done that. I think the more important question, though, is how am I going to link this formula to answer the question? How do you find identity of a substance? Now, one thing that's unique about substance, and I think probably the most common way to identify a substance is to find its molar mass. So we're going to be able to find identity if we can find molar mass. And for those who forget, the symbol for molar mass is capital M. Okay, now molar mass is, we can use triangles if you want. I'm not normally completely too fond of this, and I don't use it very often, but I think a lot of people like it. So from here, you know that molar mass is mass divided by the number of mole. Okay, so if I can find the molar mass for this gas, hopefully I can identify what it is. But the other thing that's going to be important, actually, let's think about this. We already have the mass. Okay, so the quantity that we need to find in order to get to the molar mass is the number of mole. So I am going to start by finding N, I think. I'm sketching a plan here, so we're moving on to the next step. And if you have the universal gas law, you can use it to find the number of mole of this gas sample, which is PV over RT. I'm just rearranging the formula. And then once I've found the number of mole, I think what I'm going to do is I'm going to find the molar mass, which is mass divided by the number of mole, since you're already given mass here. But then once I get to this step, let's assume that I've done all this and actually get to the molar mass. How am I going to know which one is the answer? And this is probably the other thing that people tend to forget is this is a gas, it's not an element. So you cannot assume that the molar mass of these gases will actually match the molar mass of the element, because gases don't have to be elemental. In fact, you need to have a look at this and see which gas, what the formulas of these gases are, and which gas are actually diatomic. Hydrogen is an example. Hydrogen is H2. Helium is elemental. Oxygen is also diatomic, and nitrogen is diatomic. So these gases are here. Now, I think it depends on what my answer is here, but you may have to find the molar mass of the options. They are pretty far apart from each other, but if you really have no idea, then you have to find the molar mass of the options and then match. So hopefully you'll be able to, once you find the molar masses of all of these gases, one of them will match the answer from step 2. Okay, so that's my action plan. I am going to execute it. So we have 100 kilopascal being the pressure here. So I've used this. The volume is 0.245 liter, so that's done. The gas constant 8.31 according to the data book. And the temperature is 298 Kelvin. All right, I think all the units are good. Be careful when you type things into the calculator as well, which is a very common mistake. I make that mistake a lot. All right, so I get a number of mole of 0.00989 mole or something like that. And now I'm going to find the molar mass. Mass is in gram, which is good. Number of mole is in mole. Molar mass is supposed to be in grams per mole anyway. So I don't need to do any conversion for my mass at all. So we have 0.020 divided by 0.00989. It is a good idea to keep the exact values, or as much as possible, by copying and pasting in your calculator. So I get 2.02 grams per mole. Okay, so now we are going to check which molar mass, well, which gas matches this molar mass. So definitely not C and D, because I think this is 32 grams per mole, because each oxygen is 16, nitrogen, each nitrogen is 14. So N2 is 28 grams per mole. Helium is 4, and hydrogen, each hydrogen is 1, so hydrogen is 2 grams per mole. So I think hydrogen is going to be the closest to the correct answer. So I'm going to go with A here. That's question 3.